Assalamualaikum and hello everyone. So my name is Ahmad JALIL. I will be presenting our group project for the fluid dynamic course. The title is Aerodynamics Simulation of a Sedan Car. In this project, we focus on how different spoiler design can improve a sedan's aerodynamic performance, especially at high speed. So before we continue, let me introduce our supervisor and our group member. So our supervisor is Professor IR Dr. SHAHRIR ABDULLAH, and my leader of the group is Muhammad FARIS NURAIMAN Muhammad Noor, and myself is Ahmad Aqil JALIL, and the next ZARIFF Daniel Muhammad YUSOF, and the last one is Muhammad Adam bin AMINUDIN. To solve this, we conduct a simulation using NC's front to analyze the effect of different spoiler design on airflow. Our hypothesis is that by optimizing the spoiler shape, angle, and position, that can reduce rear lift, increase downforce, and improve the car handling without causing too much drag. In this presentation, we will show how computational fluid dynamics help us evaluate and compare each spoiler's performance, and how the right design can significantly enhance both stability and safety at high speed. Alright, so for the problem statement, as vehicle become faster, aerodynamic force have a bigger impact on performance and safety. One of the main problems for the modern sedan at speeds above 100 kilometers per hour is the generation of rear lift. When this happens, the vertical force pushing down on the rear wheels is reduced. This affects tire grip, braking performance, and overall handling, especially during sharp turns or sudden movement. Drivers may experience a floating sensation, making the vehicle feels unstable and harder to control. To address this issue, automotive engineers often add the rear spoiler. The purpose is to generate downforce and push the rear of the car down to maintain traction. But not all spoilers are effective. Their performance depends heavily on how they are designed, including their shape, angle, and placement. This brings us to main research question: can we significantly improve a sedan high-speed stability by optimizing the design of the rear spoiler? So we continue for the hypothesis. We believe that a better spoiler design can enhance the aerodynamic performance of a sedan car, particularly at a high speed. By adjusting the spoiler geometry, angle, and the position, we can improve how airflow over the back of the car, reduce lift, and generate more downforce. This helps keep the rear wheels firmly planted on the road, resulting in the better grip and the handling. We also hypothesize that this can be achieved without creating too much aerodynamic drag, which means the car can stay stable while still maintaining good fluid efficiency and the speed performance.
So for the objective, the first objective to obtain the aerodynamic profile of a sedan car, and the second objective to improve the design of a spoiler for sedan cars to be useful during high speed. Next, for the methodology, the first step, we draw the geometry cut, where we are using the NC software, which is Space Claim, and the geometry shape of a sedan car has been drawn based on general model for a sedan car. And we also draw the two different design of a spoiler and assemble together with a body of the car. For the simulation, we use ANSYS Fluent, and the first step we do is a mesh generation, where we do surface mesh and the CAD model was imported, and the next we do is a volume mesh, where they generated using the polyhead score method. Next, we set up the boundary condition, which is the velocity inlet set to 31 meter per second, which is equivalent to 110 km per hour, which is the speed limit of all road in Malaysia. And we also set up the material, which is air. And next, which is the last step, we do simulation execution and baseline simulation using divine physics and mesh setting. So what we obtain is a post-processing included contours, streamlines, and vectors visualization. We also obtain the extraction of drag and lift force values for performance analysis.
So we're comparing the velocity magnitude distribution around the car. For spoiler 1, we observe a large wake region behind the car, characterized by blue and green zones. This indicates a significantly drop in air velocity, suggesting strong flow separation and high pressure drag. Additionally, the airflow does accelerate over the top surface of the car, but the spoiler design causes early detachment, forming a turbulence wake. This results in increased aerodynamic drag and less efficient airflow management. Now, looking at spoiler 2, we see more compact and streamlined wake. The blue region behind the car is smaller, indicate better flow attachment and pressure recovery. The airflow is redirected more efficiently, staying closer to the vehicle surface, which helps in reducing turbulence. This leads to lower drag and potentially higher downforce, enhance the vehicle overall aerodynamic. Now let's take a look at the airflow behavior of both spoiler examples in our chapter result. In spoiler 1, we can observe that the airflow flows a smoother and more consistent path along the vehicle. The path lines are well lined, which means there is minimal turbulence or flow separation. This indicates a more efficient flow with lower drag. The velocity gradually decreases towards the rear, and importantly, there is no major backflow or swirl, suggesting that this spoiler helps guide the air cleanly of the car. In contrast, the spoiler 2 shows on the right reveals a more chaotic flow pattern. The path lines are less organized, and we can clearly see some flow separation and turbulence behind the car. There are also regions with significant velocity drops. This indicates that the airflow is detaching from the surface, which not only increase drag but also reduce the overall aerodynamic sustainability.
So for discussion part, I will discuss about drag force. So what is drag force function? Drag force is to indicate ideal aerodynamic efficiency of a sedan car that we've been using CFD to analyze. So using two different spoiler design, which is spoiler 1 give a value of drag force slightly higher, 243.28 Newton, while spoiler 2 give value 240.35. So a lower drag force give efficiency of better aerodynamic for a sedan car with this design spoiler. Okay, moving on for lift force, still in discussion part. So spoiler 1 41.42 Newton, spoiler 2 negative 3.43 Newton. So from lift force, we can tell negative lift give a better downforce. So we can say that spoiler 2 can give downforce for a car that cruising at high speed more than 110 km per hour without any problem from lifting off the ground. So from the drag and lift force value, it will make the vehicle handling for a balanced aerodynamic efficiency and stability. So spoiler 2 is the preferred design for our analysis. So we're moving on for conclusion. So firstly, spoiler geometry will significant effect aerodynamic characteristic, particular drag and lift force, which influence vehicle efficiency and handling stability, such as our discussion for that result. So for generating downforce, which is negative lift, will improve the grip between the tire and the road and improve stability also. So producing the lower drag, it will enhance fuel economy and performance at high speed especially. So last but not least, from the conclusion, CFD will enable design optimization and provide detailed insight into fluid flow behavior around the vehicles. So that's all from us. Thank you.